Next we are discussing representation of argument of z minus z1 equal to theta by using mathematical calculation. Okay, तो यहाँ पे z क्या है? Z is moving point. So z we can take what? X plus iota y. So x plus iota y we can write x comma y. So this is moving point. And z1 we are taking as what? X1 plus iota y1. So z1 is what? X1 plus iota y1. So this is fixed point. So this one we are taking what? X1 comma y1. Okay. So first we are finding argument of z minus z1 equal to theta. Okay, so representation of this one depend on theta values. Okay, here theta can be first, second, third and fourth quadrant possible. Okay, so first we are finding this one. So what will come? Argument of z minus z1. So z is this one and z1 is this one. So what is z minus z1? X minus x1 difference of real parts plus iota times difference of imaginary part equal to theta. Okay, so this equation is very important. So this one is complex number where this one is what? Real part and this one is imaginary part. This one is imaginary part. Okay, so this is a complex number. So we are finding argument of this complex number. Okay, with theta is what? Argument. Okay, so what will come? Tan inverse y minus y1 divided by x minus x1. This is equal to theta. Okay, so from here what will come? Y minus y1 divided by x minus x1 equal to tan theta. So what will come? Y minus y1 equal to tan theta in bracket x minus x1. Okay, we know that theta can be in first, second, third and fourth quadrant possible. This is line equation. This is line equation. So if theta is first and third quadrant, then tan theta is what? Positive. Okay, then we can say that slope of line is what? Positive. Okay, so if theta belongs to first and third quadrant, because here theta can be first and third quadrant possible, yes. So if theta belongs to first and third quadrant, then tan theta is what? Tan theta is what? Positive. Tan theta is positive. That means slope is positive. Okay, so if slope is positive, we'll get one line. If theta belongs to second and fourth, then tan theta is negative. Then we'll get other line. Okay, so we are taking both case. If theta belongs to first and third quadrant, okay, then tan theta is what? Positive. Okay, so first case what? If tan theta is greater than 0, so we'll get line equation. That line will pass through point x1 comma y1. Okay, so we are taking a line. This line will pass through point x1 comma y1. Okay, and z is what? Moving point. So x comma y will move on this line. Okay, x comma y will move on this line. So x comma y here also possible, here also possible, and at this point also possible. Clear? Now here we can say that if z equal to z1, that means x comma y at this point will come. Then this will come out argument of 0, and argument of 0 is what? Undefined. That means z equal to z1 is not possible. Okay, if z equal to z1, that means this is undefined. Okay, so this point is not included. Clear? Because we are representing this one. Okay, so what you will do? It depends on theta values. Okay, so if z equal to z1, that means argument of 0 is what? Undefined. So z is not equal to z1. Okay, now here two cases possible. First is what? If theta is in first quadrant. Okay, first case is what? Theta belongs to first quadrant. Okay, it's very simple. Okay, that means in this equation if you see argument of x minus x1 plus iota times y minus y1 equal to theta. In theta is first quadrant. Okay, if theta lies in first quadrant, that means we can say that real part and imaginary part both should be 0. Okay, real part and imaginary part both should be 0. If theta is in first quadrant, then any complex number argument in first quadrant, then we can say that that complex number lies in first quadrant. That means real part and imaginary part both should be 0. Okay, so real part is what? X minus x1 and imaginary part is what? Y minus y1. So from here we can say that x minus x1 should be greater than 0 and y minus y1 should be greater than 0. So from here what will come? X should be greater than x1 and y should be greater than y1. Okay, and x comma y moving on this line. Okay, so we have to take that portion where x is greater than x1 and y is greater than y1. Okay, so there are two possibilities. Okay, x comma y lies here also and here also, below x1 comma y1 and above x1 comma y1. So we have to check for theta is in first quadrant, then which portion will come. Okay, so suppose we are taking this portion. If x comma y lie here, now you have to compare these 2 points. For comparison we can do easily. Okay, so we are comparing first x coordinate. Okay, so for that you will draw a line parallel to y-axis. So you can see this point is what x1 and this point is what x. So obviously x is greater than x1. Okay, so if x comma y lies here, then we can say that x is greater than x1, and this is what y and this is what y1. So you can compare directly. यहाँ पर हम बोल सकते हैं y is greater than y1. Correct? Okay, and if you take this point, if x comma y is here, x comma y is here, then if you draw a line parallel to y-axis, so this is what x. Now if you compare these 2 points, तो यहाँ पर हम बोल सकते हैं x is less than x1, x is less than x1, and if you compare y coordinate, so y is here and here is what y1. So यहाँ पर हम बोल सकते हैं y is less than y1. Okay, so if x comma y lies below here, then in this case x is less than x1 and y is less than y1. Okay, so we want, if theta is in first quadrant, then x should be greater than x1 and y should be greater than y1. So which portion will come? Above portion. This portion will come. That means x comma y lies above this one. Okay, so z1 is not included. If theta is in first quadrant, then argument of z minus z1 equal to theta, it will represent a ray originate from what? This point. Okay, and towards above, because theta is in first quadrant. Okay, so this is what real axis. Okay, so if you draw a line parallel to real axis, so you can say this angle is what? Theta. This angle is theta, and theta is first quadrant. Second case what? Tan theta is positive if theta is in first and third quadrant. Okay, so second case is what? Theta belongs to third quadrant. Okay, so in third quadrant, argument of x minus x1 plus eta times y minus y1 equal to theta. If theta is in third quadrant, that means any complex number argument lies in third quadrant. That means that complex number, real part and imaginary part, both should be negative. Okay, that means x minus x1 and y minus y1 should be negative. Okay, that means x minus x1 should be less than 0 and y minus y1 should be less than 0. तो यहाँ पर हम बोल सकते हैं x is less than x1 and y is less than y1. Okay, so x is less than x1 and y is less than y1. So this portion will come. Okay, so here if you check angle, this angle will be what? Theta. So this theta belongs to what? In third quadrant. So we can say that if theta belongs to in third quadrant, then this will also read, okay, emitting from x1 comma y1 and towards downward. Okay, direction is what? Down. And if theta is in first quadrant, direction is what? Above. Okay, next case we will take if tan theta is negative. Okay, second case is tan theta is less than 0. That means theta will be in second and fourth quadrant. Then we'll get this line. This line is passing through x1 comma y1. Okay, this point is not included. Okay, now there are two portions. One is this portion, other is below portion. Okay, so if x comma y lie here, x comma y lie here, then we are finding relation between x and x1 and y and y1. Okay, so for that what we are doing, we are drawing a line parallel to y-axis. So this is x and this is x1. If you compare these two, so from here we can say that x is less than x1, and if you compare y and y1, we can say that y is greater than y1. Okay, so for this portion, if x comma y lies above, then x is less than x1, y is greater than y1. But if x comma y is here, okay, x comma y lies in this portion, then what is the relation? Okay, so for that we are drawing a line parallel to y-axis. So this is x. Now here we can say that x is greater than x1. X is greater than x1. If you compare y and y1, then we can say that y is less than y1. This will come. Now here, if theta is in second quadrant, okay, if theta belongs to second quadrant, this is third case. Okay, so if theta belongs to third quadrant, this is complex number. So any complex number argument lies in second quadrant, then we can say that real part should be negative but imaginary part should be positive. That means x minus x1 should be less than 0 and y minus y1 should be greater than 0. So from here what will come? X is less than x1 and y is greater than y1. Okay, so this we have to find out. So x comma y lies here, then we can say that x is less than x1, y is less than y1, y is greater than y1. So this portion will come, this portion will come. Okay, so it is a ray emitting from x1 comma y1 and toward this one. Okay, so if we take line parallel to real axis, so this angle is what? Theta. Okay, angle we have to count in anti-clockwise direction. So this is what? In second quadrant. Now next case what? If theta lies in fourth quadrant. Okay, fourth case is theta belongs to fourth quadrant. Okay, so for any complex number, if argument lies in fourth quadrant, then we can say that real part should be positive but imaginary part should be negative. So x minus x1 should be greater than 0 and y minus y1 should be less than 0. So from here what will come? X is greater than x1 and y is less than y1. Okay, so we want x is greater than x1, so this one will come, and y is less than y1, that way this will come. Okay, so in this case your x comma y lies here downward. Okay, so point will be what? This is also ray emitting from x1 comma y1 and towards the down. Okay, direction is this side, and here also angle, if you check, this angle is what? Theta. So you can see theta is one fourth quadrant. Okay, we have to count angle in anti-clockwise direction. Okay, so this is your diagram.